In some of the earlier videos, I've shown you how to draw different types of graphs. In this video, we're going to assign names to each of those graphs. It's important to have names because it helps us to communicate with each other. So a straight line will be in the form of y equals mx plus c. Now, whenever you have a straight line, it will be a linear graph. Okay, so for example, y equals 7x plus 2. This is a linear because you look at the power here. This in effect is a 1 here. Well, when it's to the power of 1, then it's a linear graph. So this here is a linear graph. Okay, okay, it's a linear graph. This here, well, whenever you have y equals x to the power of 2, then this is a quadratic. Okay, these names just help us to communicate with each other. It's useful for us to be able to communicate with each other. So here, this is a quadratic. So here, y equals 3x squared. This is also a quadratic. Y equals minus x squared. Remember, minus x squared, it means this. You've got to visualize it like this because powers are more important than minuses. So you've got to do what's inside the bubble first, and then, well, y equals minus x squared will look something like this. Okay. So that's a quadratic as well. And even if you have something like y equals, let's say, 7x squared plus x plus 3. This is here you've got a combination of a linear and a quadratic, but in this case it's called a quadratic, even though you've got a mixture of the two, because later on I will show you why. But this term here is actually more powerful than this term. It actually behaves like a curve, even though you've got some sort of linear components of it in here. The overall behavior of this whole line, it behaves like a U shape. So I'll explain more of it as we go on. But so even if you have y equals, let's say, 3x squared minus 7, say, this is a quadratic as well. Even if you have like y equals 4x squared minus 3x plus 4, even though you've got a linear bit inside there, overall it behaves more like an x squared, and you will see why later on. Okay, this one here, y equals x to the power 3 is called a cubic. Okay, cubic graph. And if you have again, if you have a mixture in here, let's say x to the power 3 plus 4x squared plus x 7x minus 3. Even though you've got other bits in there, overall it actually behaves like this, and you will understand why later on. I will explain it later on. Overall, the whole behavior of this, it will behave like an x to the power of 3. Okay, and if you have y equals minus x to the power 3, remember this behaves like, you've got to visualize it like this, because you've got to do the power first and then stick a minus in there. Well, hang on, y equals minus x to the power 3, it will actually look something like this. It will look something like that. Oh, it wouldn't curve back on itself. It will look something like that. Okay, what y to the power of it will look like this. This is y equals minus x to the power 3. X to the power 3 will look something like this. Okay. Well, anyway, remember this to the power 3 would be cubic. Okay. And y equals 1 over x. It will be a reciprocal. Okay. And try and understand why this is. Why it's like this? Because well, when you have 1 over y equals 1 over x. Now, as x gets really big, so it will be y over 999. As x gets really big, the overall the overall number here will be really, really small. So that's why it's heading towards 0. But it will never be 0, because if you get your calculator and do give it a really big number, the overall number here will be very small, but it will be a positive small. It will never jump to a negative answer. It will, because here you've got a positive and a positive. It will always, well, yeah, to try and understand why is it that when you have y equals 1 over x, it behaves like this. So as you make x really big, this overall thing will be really small. See? Now, as you make x, let's look at around here. As you make y equals 1 over, as you make x really small, near to 0, but not 0. Okay, not 0. So let's say 0.00001. This overall thing here would be very big, will be really big. That's why it goes up here like this. Okay. When you have a number that's really close to 0, it will be, the overall number will be really big. Now let's look at this bit here. Let's look at y equals 1 over x, where x is right next to the 0, but on the left hand side. So it would be 1 over a really close number, a number that's really close to 0. So let's say 0.00003, say, and it's on the negative side. So you've got to stick this minus in here. Now, so if you look at a number that's really close to here, okay, near to 0, but on the left hand side, that's why we've got a negative here. Now, just concentrate on this bit here only. Okay, 1 divided by a really small number, then this whole thing here would be really big, really big. Okay, the overall thing would be really big. But because you've got a minus here, then it would be a negative really big. That's why it's a negative really big. That's why it goes all the way down here. If you look at this reciprocal graph, that's why it's really big. Now if you hang on. If you look at when x goes when x is really negatively big, so y equals 1 over x, but let's make x really negatively big, if that makes sense. Okay, so 1 over minus 999, say, really big, but on the negative side. So let's just visualize this bit only, without the minus. Okay, so we are the answer would be minus later on. Now if you just look at this bubble only, 1 divided by a really big number, then the overall answer here would be really small, 0.000 I don't know, 1 blah 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 blah, and then you stick a minus in here. So when you look at this here, when x is really big but on the negative side, this overall bubble here would be really small, because 1 divided by a really big number here, the overall thing would be really small. Now you've got a minus here, don't forget, so it's going to be minus really small. Okay, and it's going to be a minus really small. So that's why it's like this. It's really small because it's 0 point something, but it's on a negative side. So it's negative really small. So when you plot something like this, minus 0.00003, say, it's going to be somewhere here. It's going to be somewhere here, really close to the that's why just understand that okay, this is a reciprocal graph. Okay, and then also we have y equals, let's say 2 to the power of x. Now this here is exponential graph. Okay, so this here would be 1, and remember, if you have y equals let's say so suppose you have y equals a to the power of x. Now if a is greater than 1, if a is greater than 1, then it's going to grow. So this thing here is going to grow. Now if you have a where a is less than 1, it's going to decay. it's going to get smaller and smaller. Okay, so hang on. So this graph here could represent y equals 2 to the power of x. It's going to grow. Okay, it's called exponential growth. Okay, when this number is bigger than 1, it's called growth. Exponential growth, because it grows. It gets as you increase x here in this direction, it grows. But then if you have y equals, let's say 0.7 to the power of x, the graph will look something like this. It's going to look something like this, and it will head towards 0. I've already explained this, why this is the case. If you don't understand it, watch one of the earlier videos. But because this number here is smaller than 1, it's going to get, as you increase x, it's going to get smaller and smaller and smaller. It's called exponential decay. Okay, decay. Now if a is above 1, it's going to grow. So it's called exponential growth. Okay, so hang on, let me just so y equals, let's say 2x. Well, it will look something like this, and if you have y equals let's say 4 to the power of x, it's going to decay. So it's going to decay. So it looks something like badly drawn. It's going to look something like that. Okay, it's going to decay, and this here is always 1, because anything to the power of 0 is 1. Okay, yeah, okay.